Symmetry in nature refers to the balanced and harmonious arrangement of parts in a natural object or phenomenon, which often allows certain mathematical patterns. It can be observed in various forms in both living organisms and physical structures. Mathematically, symmetry is defined as invariance under a specific transformation, meaning that after a transformation like rotation, reflection, or scaling, the object or system still looks the same. Here are some examples of symmetry in nature.
Hi, I'm Micaela Emertea, and let's talk about the different types of symmetry found in nature. So first is rotational symmetry. This type of symmetry occurs when an object looks the same after being rotated around a central point by a certain angle. The object maintains its shape and structure after each rotation, and this kind of symmetry is also called a radial symmetry when it applies to circular patterns. So for example, examples of this in nature is flowers like daisies and sunflowers that often exhibit rotational symmetry, where their petals are evenly placed around the center. The second symmetry is translational symmetry. Translational symmetry occurs when a shape or patterns repeat itself over a certain distance in a specific direction. This form of symmetry is common in nature's repeating patterns, allowing structures to be extended indefinitely without changing their basic form. So examples of this in nature is honeycomb structures created by bees that showcase translational symmetry. The repeating hexagonal cells maximize space efficiency and structural strength. Snakeskin patterns and fish scales also displays translational symmetry, where identical shapes repeat seamlessly along the animal's body, providing both protection and camouflage.
An object exhibits reflectional or mirror symmetry if one half of it is a mirror image of the other. This is common in many animals and plants, like the bilateral symmetry in the body of humans, butterflies, and starfish. Fractals are structures that repeat themselves at different scales, such as the branching patterns in trees or the shape of coastlines. In mathematics, fractals are described by self-similarity, meaning parts of the object are geometrically similar to the whole, albeit at different scales.
Next is let's talk about spiral symmetry. Spiral symmetry occurs when a shape is repeated while rotating and expanding from a central point. This type of symmetry often follows the Fibonacci sequence or a logarithmic spiral, which provides an efficient way to path or grow in a confined space. So examples of this in nature is turtle shell that grows in a perfect logarithmic spiral, which allows the organism to maintain its shape as it increases in size. Sunflower seed heads display spiral symmetry also through the Fibonacci sequence, optimizing the packing of seeds to capture the maximum amount of sunlight and space. Let's talk about why math in nature is fascinating. First, math provides a universal language that describes patterns, structures, and relationship in the natural world. From the symmetry of flowers to the spirals of galaxies, math governs the most intricate designs in nature. This connection between math and nature is not only beautiful, but also serves as a practical purpose. Symmetry can enhance survival, efficiency, and reproduction. So by studying these patterns, scientists and mathematicians can uncover the hidden rules that guide the universe, showing us a deeper appreciation for the elegant and interconnectedness in the world that we live in. That's all.
Symmetry plays a vital role in nature for efficiency in growth, energy conservation, and even evolutionary advantages in organisms. It can also be observed in the molecular and atomic structures, where symmetrical patterns like hexagons are present in things like honeycombs or crystal formations.